Hello and welcome to another exciting episode of Let's Program. Today we're going to sort of continue on with the number game that we started last time, but we're not going to be working directly with the project. Today we're going to design a test project so that we can look into the random generator, basically the random class, and basically the method in which we plan on using to design the random numbers used in the game. Basically what we want to do is we want to create an array where we can then save how many times a specific index is called and then create a report so that we can see on average how many times a specific index is called, the deviation from that average, the minimum and maximum, and just a whole bunch of things. Maybe this sounds a little scary. It isn't. Today I created something called a structogram, which is going to help us see sort of what we want to do, where we want to go with this, and it's a really good tool to use in case if you want to visually express to somebody how a specific method should work. I just made one structogram for multiple methods. Basically, I just want a very wide overview of what I want to do. And this is it. I don't know how this is going to look on the video, so I'm going to scroll in a little bit further and go to the top. This part up here, I'm basically saying what objects are going to be there from the beginning. I'm going to say that I need to have an object from the random class. I'm also stating that I want to have a maximum of 1,000 numbers. That actually isn't exactly accurate because we're forgetting here that we want to include 0 and we want to include 1,000. So we actually need 1,001. But at any rate, 1,000 is going to be the maximum used integer. We're also going to need an array, and this array is going to have 1,001 indices. Again, this is because we're including 0. I was trying to figure out a good amount of times to generate random numbers to test this, and I came up with a nice round number of 100 million. This means that it's going to take a little while, however, it's going to be more accurate than if we chose a million. We could use more, we can do less. I chose 100 million pretty randomly, actually. Here we have a loop, and I'm going to be using a for loop, just a different version of this because I think it's going to work out better. Basically all what we want to do is make sure that every single integer in this array is set to 0. Then what we're going to do is we're going to fill this array, and we're going to, again, in a loop, first come up with a new random integer, and then we're going to put it into, we're going to find that integer index, and then we're just going to set that integer up to 1, as in we're counting how many times that particular index has been counted. Then we can calculate our average and we can display this report to the user. And we're going to do this on the console. We're not going to use any sort of user interface other than just the Eclipse console. We're first going to declare an integer, and we can really call that integer whatever we want, but I plan on calling it total. We're first going to set it to 0. Then we're just going to add up how many times all of the indexes were called, and then we're just going to divide that by the total amount of possible indices in this array. Again, here's the loop where we count everything. We're going to save that average in a variable for later use, and we're going to be putting it into the console. I wrote here syso because if you type in exactly this into Eclipse and then press Control and then the space bar, system.out.print will actually automatically show up. So that's why I chose to do it that way. We're then going to calculate the range of how often these particular indexes were called. What was the minimum, for example, was index 0 called 20 times, and that's the absolute lowest, and was index 50 called 200,000 times, that's the max. I want to know what this is. So basically what we have here is first we're setting we're setting the minimum, we're setting the maximum. A maximum is definitely going to be higher than 0. Minimum is definitely going to be less than 100 million. So we're taking that as our base. And then what we're going to do is we're going to look in every single index, see if it's less than the minimum. If so, we're going to rewrite minimum. We're going to do the same thing again here with the max. If the max is, if the amount of times a particular index was called is greater than what's already set for the maximum, we're just going to reset the maximum. And then again, we're just going to display this in the console. We can then look at page 2, and here we're now going to figure out the deviation from this average. Again, I want to also know what the minimum deviation is and what the maximum deviation is. And again, maximum is definitely going to be higher than 0. Minimum is definitely going to be higher than 100 million. That's why I chose those numbers. Again, we have a for loop here, written exactly the way we're going to type it in when we start programming. And then we're going to just calculate the particular deviation for this index. To do that, we're just going to take the absolute value of the value minus the average. We're then going to add that to a variable called deviation total so that we can then calculate the average deviation later. And then we're just going to, again, with these two if statements, figure out which one was the minimum, which is the maximum. And then we're just going to, again, display this all to the user through the console in Eclipse. Pretty easy, and we can then change things around later, but for right now we're going to just keep it the way it is. That can be closed. We're going to open up Eclipse, and we are going to start a test project. It can even be called test project. Because it is just a small test project and we don't plan on keeping it, we could just put our one and only class directly in the default package. However, to stay in the practice of using packages, we're just going to make one. It doesn't really make that big of a difference anyway. And we're going to create a new class. Okay, superclass is going to remain object, and we do need a main method, so we're going to keep all that in there, and we're just going to hit finish. we don't need to worry about Java doc, so that can just go away. And so that we don't have any issues with static variables and all of that, we're just going to create a constructor here. And I am actually going to create a method called reset, and reset is where I'm going to do such things as setting up the array and everything. I feel that that's going to work best in the long run, because then we have the ability of resetting test project rather than creating a new object later on. I just think it's going to help later on. So from test project in the constructor, we're just going to call reset. Well, what type of objects do we need? Well, first we already discussed that we're going to need an integer array. I'm intentionally leaving something out right now because I actually want to very easily change how many indices this array can have. So I'm just going to create another integer here. And then here in integer, I'm just going to type that in. Now we can look again on in our structogram what exactly we wanted. We also need a random object, and we need to know how many times we're going to run through the loop. And then we need our maximum. Okay. Now before we continue, I just want to quickly show you the documentation for the random class. So let's open that up. And I want to show you that there are two constructors. There is first the basic constructor that doesn't take any arguments. And then there's one that takes a parameter of type long, and that's going to be the seed. We're not going to deal with that. Down here, this is probably the most important part. We're going to be using the method nextInt. NextInt takes a parameter, optionally, and that integer is going to be the maximum. Basically, we need to just then know that 0 will be included, and that maximum will not be included. Okay, so we're ready to begin. First thing that we're going to want to do is we are going to want to clear our array. as we said here in the structogram, we want to do this loop here. And in that loop, we're just going to set everything to 0. For those of you unaware of how this loop works, we're first going to declare a variable to count how many times we're running through. We're then going to say that this loop needs to just keep running until this condition is met. In other words, until I is no longer less than the length of the array. And every time the loop finishes, this integer should be counted 1 time higher. So now what we can do is we can say that the result array integer found with the index of I should be set to 0. Very simple. That's going to set everything back to the way it should be. Now let's look at what we wanted to do next. Now we wanted to have another loop where we actually generate, this is where all of the test data is going to come from. So let's go back into Java here, Eclipse here. And now we're going to do another for loop. I can use I here because this variable I only worked in the scope of this for loop. It doesn't exist here anymore, so that's why I can use it again. That's sometimes a problem if you are using JavaScript, as far as I've seen in my tests, but in Java it's not a problem at all. So in this, we're going to want to say that int this random is equal to ran dot next int, and remember that we want that to be the same as our max index. Alright. That's it for that for loop. When that's done, we can then calculate all of the everything we wanted to display to the user. For that, I'm actually going to use another method. We're going to call that write report. And we can just put that right down here. So let's calculate our averages. For this, we're going to need an integer called total. We're just going to set that equal to 0. Then we're going to create another loop that says for int I 0. In order to be able to use this in other methods, I'm going to put it up here. When this is reset, I want to make sure that that's set to average, or set to 0 rather. And here I'm just going to say average is equal to the total divided by result array dot length. And I want to print this out. Alright, so a couple things to note. This here is very helpful right here. This notation plus equals is very helpful because it's going to take the total and it's going to add total plus result array, whatever is in this slot right here, and it's going to make total equal that again. So this is the same as saying total equals total plus result array location I. This right here, because average is an integer, even if this calculation here were to return a decimal value, so a double value, it's just going to round it, not necessarily correctly, but it's going to make an average nonetheless to the nearest integer. Then we're just going to print that out. What we can do here is we can write a comment that says calculate average just calculate average. Also, so that we know what we're talking about here, we're going to have to say that the average okay. Moving along. Let's look at what we wanted to do next. So we calculated the average. Now we want to calculate the range. And again, we can even make another method here. Normally I'd probably, well, I don't know. I don't know if I would normally put this in so many little sub-methods. More than likely I would just put it all in one. I mean, it's not like it's that major here, but I've changed my mind here. I want write report to just call a whole bunch of other methods. So let's write private void calculate average. And then we can just move all this over here. And then we can just make the call from write report. Now the report's also going to have to do something else. We're going to have to calculate the range here. So calculate range. How do I see this? I also want to change this to public. Reset should also be public. Next is calculate range. Let's look at our structogram again. We need an integer maximum and an integer minimum. And then we need our loop. And now we're going to go through these if statements. Okay, and that's pretty much it for that. Just some things to go over. This here could have been done in an if-else statement. However, I felt that it was best for it to be in two distinct if statements. That's more or less just in case if the same number for the minimum just happens to be the same number of the maximum, both will be set. Again, that's very, very unlikely. In order for that to happen, there would have to be only one, everything would have to be called the exact same amount of times, and that is very highly unlikely. But anyway, that's it for calculate range, with the exception that we're going to need to display this information to the user. So, okay, and that's it for calculate range. And that's also everything for page 1. Now we're going to go into deviation, average deviation, maximum deviation, minimum deviation. So, in order to do this, let's first create a new method, write report, and we're going to call it calculate deviation. Oh, you deviant. Okay, we're going to need a minimum. And again, we're going to be needing our for loop. Okay, so let's look again in our structogram. Let's figure out what we want to do. We wanted to find the absolute average of this calculation. So let's take care of that. And we also need another integer, and that's the deviation total. the math object has a method called ABS, which is a static method, which means it's always there. We do not need to create an instance of a math object in order to use this method. And that just creates the absolute value of this integer. Alright, so we have our this particular deviation calculated. So what we want to do is we want to add this to the total. Deviation total plus equals this deviant. And then what we want to do is find out if this is the minimum or maximum. So, just as before, and because I'm getting lazy, we're going to copy and paste. Not too much. And we're just going to change this here to this deviant. Oh, okay, we have to indeed change this. We're going to say this. Oh. This deviant is less than the min. Then min equals this deviant. Otherwise, then the max is going to equal that deviant. Okay, and again, all what we need to do now is just print that out for the user to see. So we're going to say Sizzo. Sizzo! Sounds like a dog's name. Sizzo! Or a character on the Hunger Games. Anyway, we're going to say average deviation is equal to plus might as well put it in there. Deviation total divided by results array dot length. Sizzo minimum deviation is equal to the min and we're going to say the maximum deviation is equal to the max. And that's pretty much it. All that we have to do now is, and I'm going to change how I did this. I'm actually going to get rid of this whole constructor here to show you that you don't need it. I'm going to first call, I'm going to save it first. I'm first going to call the default constructor. TP, not to be confused with toilet paper, equals new test project. And we can see that there is a default constructor. It's there just because it is. The second we were to create a constructor that takes a parameter, this default constructor would be gone and would no longer exist unless if we were to create it again. That's basically what we did in the number game. I'm just telling you, you can do it this way, you don't have to. But then we're going to call reset. Then we're going to call write report. And then we're just going to wait. But before we do that, I want to know how long it's going to take to calculate, to run through this array. Alright. In case if you're wondering what I did here, and I also did this in another way to write the if clause, I just said that if the remainder when I is divided by, should be 100,000, yeah, when I divided by 100,000 has no remainder, and when it's equals 0, then it should say that it's calculating, and it should give me how many it's worth. Could be that I made a mistake here, but I doubt that I did. Anyway, let's set this running. Okay. Not exactly what I was expecting. Okay. What does bother me is that the minimum times generated is remaining at 0. I'd want to just see if I made a mistake there. Okay, it does indeed look as though I have made a mistake here. I have confused these two. That should be a 0. And just checking this, max should be 0, min should be times to run. Yeah, so when we press play now, we'll see there we go. And that is now the correct, that is exactly what I expected. We could expand this to include a lot more statistical information. However, that's basically what we want. Anyway, thank you very much for watching this. I hope that it has been helpful. and it will most definitely give us a hand later on when we want to go into our random number generation. And we do see that indeed, once we take out the programming errors, we do see indeed that this random number generator is pretty good. Alright, so thank you very much, and I will see you next time.